Okay, so we have this one problem here. It says a scale on a map says that 2 centimeters represents 3 meters in real life. So that's our scale. Part A says if a pathway measures 8 centimeters in the drawing, how much does it actually measure? Okay, so again, we're given a problem about a scale drawing. They give us the scale. So first thing we want to do is make our table. Right, so when you're given your scale, you want to make a table that uses the scale, not scale. Yesterday we said drawing on one side and then actual on the other side. So we're comparing drawing measurements to actual measurements. The scale they give us is that 2 centimeters on the drawing represents 3 meters. In real life, then they tell us that there's a pathway that measures 8 centimeters in the drawing. So that's a drawing number. So I'm going to put that on the drawing side. How much does it actually measure? So what is the actual length of that pathway? Okay, so similar to how we worked these problems out yesterday, every 2 centimeters represents 3 meters. So if we have 8 centimeters, that is 4 sets of the 2 centimeters, 4 times bigger than that. So 2 times what gives us 8? Well, that's 4. If we're multiplying that by 4, we have to multiply the actual corresponding distance by 4 as well. So 3 meters times 4 gives us 12 meters. So our answer for A is 12 meters. Now part B says if a tree is actually 4.5 meters tall, how tall would it have to be in the drawing? So they tell us 4.5 meters tall is the actual distance, the real life distance. So that number has to go on the actual side. And we want to know how tall it would have to be in the drawing. So again, we're going to go from the scale that they give us to that new number. So from 3 meters to 4.5, you should be asking yourself 3 times what gives us 4.5. That one's not as easy. So we are going to set up an equation to figure out what that number is that we're multiplying by. So 3 times what, we're going to call it x, is equal to 4.5. So here, this number, this unknown number, is represented with the variable x, and x is being multiplied by 3. So to isolate that variable, to get the x by itself, we want to divide by 3 because that's the opposite of multiplying by 3. And that gets rid of the multiplying by 3 because 3 divided by 3 is 1, and 1x is just x. Now, whatever we do to one side of the equation, we have to do to the other side of the equation. So now we have to do 4.5 divided by 3. So you guys can divide that out by hand. I'm not going to go through the whole thing, but when you divide that out, you get 1.5. So that means 3 times 1.5 gives us 4.5. So we are making that actual distance 1.5 times larger. So we have to make that drawing distance also 1.5 times larger. So now we do 2 times 1.5, which is like 1.5 plus 1.5, which gives us 3. And then we cannot forget our units, centimeters. The drawing uses centimeters. Okay, so we talked about 2 different ways to solve this problem. That was one way, right? The second way is finding out your rule. How do you get from drawing to actual? So 2 times what gives me 3? 2 times what is equal to 3? So same thing as before, divide both sides by 2 this time. So x is equal to 3 over 2, or that's 1.5. So to go from the drawing number to the actual number, you are multiplying by 1.5. So for every 2 centimeters, you have 1.5 times that many meters. Right? If we were to check, 8 times 1.5 is 12. Oops, that's a 1. Now that's if you're going from drawing to actual. On part B, we were going backwards from actual to drawing. So instead of multiplying by 1.5, we would have to divide by 1.5. And 4.5 divided by 1.5 gives us 3. Okay, so I just showed you guys 2 different ways to get to your answers for A and B.